In question number 3, we're going to try to piece together what we learned on the previous page in order to really start to make sense of how these equations work and how we can interpret their equations as actual sequences of numbers. In number 3, letter A, they're going to give us enough information to fill in this table. We just need to make sure that we practice translating the information into specific things that we can look at in the table. For example, the initial value is something we heard about on the previous page. The initial value is always the 0 term in the table. So you'll see I'm kind of color coding there. The initial value is always the 0 term. And that's something you can do in every question. Initial value, 0 term. If you want to color code that on every problem so that you have access to something that visually just kind of reminds you of what to do, this might be a good habit to start. In any case, the initial value is always the 0 term in the table, so we can automatically fill in our table value of 4 because we know that's where it goes. The initial value is always the 0 term in the table. The multiplier tells you how to get the next numbers in the table. So the multiplier essentially tells you what to do in order to fill in the next blank space. This is telling me to take my 4 and multiply by 0.5 in order to get the next number. If you don't feel confident that you can multiply that, especially if you have hesitations with decimals, it's completely fine to use a calculator, especially if it just makes you feel more confident. 4 times 0.5 would be 2. So that's telling me that the next blank space in the table is going to be a 2. And if that multiplier keeps going, then I can assume that every time I need to get a new number in the table, I'll just multiply by 0.5 again. So 2 times 0.5 would give me 1. Notice how each time I'm going to keep multiplying by that same value, 0.5. If I multiply again, 1 times 0.5, that gives me 0.5. And some of these you might be thinking, oh, that's easy, I can do this in my head. And that's great. Use a calculator, use your head, whatever works better for you. But if you keep the pattern going, 0.5 times another 0.5 would be 0.25. And if I multiply by 0.5 one more time, whoops, then I should be able to get 0.125. We're definitely starting to get decimals, but that's okay. The pattern is such that I'm just doing the same thing over and over again. Multiplying by 0.5, multiply by 0.5, multiply by 0.5, multiply by 0.5. It just keeps going and going. Now, as I look at the numbers, I can tell that they have gotten smaller. I started with 4, which is not that big a number, but I got the next one was 2, that's even smaller. I got the next one was 1, that's even smaller. Then I started to get numbers less than 1, it's even smaller. So I can tell that this pattern is decreasing because the numbers are getting smaller and smaller as I move through the table. The last thing it wants us to do is to write the equation. And this is where you might want to revisit what we observed on page 3. We know that this is a geometric sequence because it's multiplying something. So I'm going to go back and use the template at the bottom of page 3 as an example of what a geometric sequence should look like. I need T of n equals initial value, parentheses, multiplier, power of n. If you find it a little annoying to have to flip back and forth, you can quickly copy that note to yourself so that you know what to do. T of n equals initial value times, or parentheses, multiplier to the power of n. Now, of course, I don't want to write that in my answer space. I want to write numbers in those spaces. So I'm going to copy into my answer space the T of n equals. That's just proper notation, and you'll see that notation all the time. But now let's think about numbers. We had already said that the initial value is 4 because they gave us that, and we knew that from the table. So I'm going to put a 4 for the initial. Parentheses. They told us the multiplier is 0.5 because that was what we were multiplying by. So 0.5, close my parentheses, to the power of n. Notice how I did make n look like a power. I wrote it teeny tiny compared to the size of the other things that I wrote in the answer space, and I made sure it looked like it was lifted up in the air, like a proper exponent. Now that you've seen that example, though, question letter B is very similar. In fact, you might immediately think, oh, Herbert, it's a typo, it's the same question. It's similar but not the same. This one also has an initial value of 4, but this time the multiplier is 2. So try this one for yourself, see if you can make some sense of it, and then check the answer key and make sure that it makes sense. If you feel like that one makes sense, then go ahead and try letter C. If you don't feel confident, the next video will go over letter C, but as you know, my policy with videos is always watch what you need and skip what you don't. If you feel like you get this, do B and C, and don't watch anything in the next video, or skip altogether. If you feel like you need a little bit more structure, the next video will go over letter C, but either way, you're on your own for letter B a little bit. Try it and use the answer key as your guide. If it still doesn't make sense and you don't feel like you can go any further because you feel very stuck, plan on making some time for the office hours at the next available opportunity, sometime that you're free at noon, and pop in to ask a question. Maybe that will help clarify so that you can finish it with a little bit more information.